All right, here we are with part 2, finishing up our in-class video review. So, if negative 3i and root 7 are roots of polynomials, what are the two remaining roots? Great question. What do? We do the conjugate. So if negative 3i is a root, then I know positive 3i is also a root. If root 7 is a root, then I know negative root 7 is a root. Although the problem is not asking us this, all of the roots are x equals negative 3i, x equals 3i, x equals root 7, and x equals negative root 7. Pretty straightforward, hopefully. Moving on. Write the factor form of a polynomial with a root of 0, with a multiplicity of 3. Ooh, 3. All right. A root of 4 with a multiplicity of 2, and a root of negative 1 with a multiplicity of 2. We are not multiplying this out. What does this look like? Great question. I'm going to keep stalling just in case you wanted to try this on your own. You could pause the video, but I'm going to go ahead and do this now. So p of x equals, if I have a root of 0, so think about that, that would be x equals 0, so the factor is just x. So that's going to be x to the third power. Then we have a root of 4, so the factor is going to be x minus 4, has a multiplicity of 2. And then the last one, we have a root of negative 1, so the factor is x plus 1, but we have a multiplicity of 2 again. There we go. Any questions? All right. I would point out on problems like that and the previous one, and this as well, there's very little work involved. So it's just really understanding roots, factors, polynomials, all that fun stuff. Okay, same thing here. All we're doing is identifying some information. Go ahead and pause the video if you want. Try it on your own. Otherwise, just listen to me ramble again. Degree, 3. Leading coefficient, negative 2. Ordered pair for the y-intercept. How do we find a y-intercept? Good question. Plug in 0 for x. And remember that it's always going to be the number without x. So our ordered pair is 0, negative 4. Max number of terms. How do we find that? Well, that is always the degree minus 1. So 3 minus 1 is 2. Excellent. End behavior. How do we do that? Well, here we have to look at the degree and the leading coefficient. If the degree is odd and the leading coefficient is negative, then as x goes to negative infinity, y will also go, whoops, I messed that up. Y will go to positive infinity, sorry. So as x goes to negative infinity, y will go to positive infinity. And then as x goes to infinity, that is where y will go to negative infinity. Last one. Okay. Identify the symmetry and if the graph is even, odd, or neither, if the function is. Sorry. First thing, symmetry. What does this look like? It looks symmetrical to the y-axis. Great. If a function is symmetrical to the y-axis, then the function is even. All right. What does this look like? Symmetrical to the x-axis. If it's symmetrical to the x-axis, then it is not even or odd because it is not a function. How about the last one here? This one looks like it's symmetrical to the origin. Very good. And remember, origin is our rotational symmetry, so if you were to visualize rotating this 180 degrees, it would land on itself. So this is origin. If something is symmetrical to the origin, then it is an odd function. Any questions? Excellent. That's the end of our review. Nice work.